Hello, Math 3 students. I'm working a few problems from the classwork 151 on exponentials and logarithms being inverses of each other. In an attempt to help you as much as I can, I thought, first of all, I marked out some on your PDF that you're working on, and I thought I would work a few of these with you because you got the lesson during the live lesson and you're kind of on your own with the classwork. So this video is to help you out with the classwork. So this is number 4. And what I want you to understand about this top section, numbers 1 through 6, these are not exponential functions. You see how the x is not an exponent. If the x is an exponent, that's when you have to use logarithms to find the inverse. But these are not exponential functions. These are like the ones we did last Thursday when we were doing inverses. So to find the inverse of number 4, for example, and I think there was one other one in this section that you had to do. This is the one where we change this to y, and then we switch the x and the y. So we say x equals 5/3 y plus 10. And then we solve for y. Well, y is not an exponent, so I'm not going to need to use logs for this. I just solved for y on this. So remember, we're going to undo what's been done in reverse order. And so the first thing I'm going to do is subtract 10 from both sides. Now, x minus 10 is just written x minus 10. There's really no other way I can write that. These cancel out. 10 minus 10 is 0. So x minus 10 equals 5/3 y. A couple different ways we could do this. The first thing I would probably do is I would probably multiply times 3 on both sides. And that way, when I multiply over here by 3, these 3's cancel, and this is going to be 5y on the right side. And then when I multiply over here by 3, I can put it on the outside like this and use distributive property. That's going to be 3x minus 30 equals 5y. So then the only thing I have left to do is divide by 5 on both sides. And I've got the y by itself. So y equals, and you can leave it like this, 3x minus 30 over 5. You can leave it like that, but I would like to see you rewrite it in inverse notation. If you wanted to rewrite it where you didn't have this whole thing over the 5, you could rewrite 3/5 x minus, and then 30 divided by 5 is 6. So that's another possibility. But this one I would count correct as well. Okay, so that was the first section. The next section is exponential functions, because as you can see here, the x is actually in the exponent. So if the exponent is what we don't know, we're going to have to use logs to solve this. So we're going to have to rewrite this as a logarithm, but not until, let me get my highlighter here. What we need to isolate is the base and the exponent. So that part right there is what needs to be isolated. So to do that, I'm going to change this to y, and then I'm going to switch this to x equals 10 to the y minus 8, and then that minus 6. I'm going to highlight that again. What needs to be isolated is this part right here. I need to get that part by itself, and then I can rewrite it as a log. So if I add 6 to both sides, that's going to isolate it. X plus 6 is just x plus 6. Okay, so now I have my base and my exponent isolated, so I can rewrite this as a logarithm. But what I want to do first, I'm going to get my exponent on the left. It's just a thing with me. You don't have to do that, but for me, it makes it easier to rewrite it like this, because then I can see this is my base. I'm going to highlight it. This is my base. This is my exponent. And then this is I don't think that has an official name. It's kind of just the answer. Okay. So when I rewrite this, log, my base goes down here, so 10 goes there. And then this part right here is what goes in parentheses right here. X plus 6, 6 equals, and then my exponent goes over here. So I'm going to just color those again real quickly. So the exponent is there. This part right here in parentheses is right there. And then my base, which was the 10, is right there. So that's where everything goes when you rewrite it in log form. And then I just need to add 8 to both sides to get y by itself. I'm trying to get y by itself. So plus 8 and then plus 8 over here. And it's just going to go on the outside of the parentheses. So it's going to be log base 10. And remember that 10 is the common base. If you didn't write a 10 right there, it wouldn't be wrong. X plus 6 in parentheses, and then on the outside of the parentheses, plus 8 equals y. I'm just going to check my key real quick to make sure I got the same thing. I did. Okay, so then I'm going to rewrite my original, my h of x. I'm going to rewrite it in inverse notation. The inverse of that equals, and then I'm just going to put all of this part right here over here. Log base 10. Let's see if I can move this up a little bit. My pen messes up at the bottom of my tablet. And then this is x plus 6 plus 8. So that is the answer right there. So if you start out with an exponential where you've got a variable in the exponent, you're going to end up with log form. All right, the next one I wanted to do with you is number 14. That is in the next section, I think. And these are the ones where we start out with a log and we're going to end up with an exponential statement. So let me look at number 14. Okay. So first thing I want to do, let me grab a different color here. I'm going to change this to y, and then we're going to switch the x and the y. So x equals, just rewrite everything, but put y here. Okay, now let me show you what we need to isolate this time. So when we start out with a log equation, and we want to change it to exponential by finding the inverse, we want to isolate, oops, I thought I had a highlighter. There it is. Okay, we want to isolate this and what's in parentheses. Okay. I was thinking this looks like this is really similar to the one we just did. Is it the one we just did? X plus, oh, it's similar. It's not the same. It's got the plus 8 on the outside of it. That's why I was looking at that weird. Okay, so I need to isolate this yellow part. To do that, I just need to subtract 8 from both sides. X minus 8 equals, just rewrite everything over here. Okay. So now I'm going to rewrite it. Again, it's just me. You don't have to do it this way, but I like to rewrite it where this part is on the left side. Log base 5, 6y minus 7 equals x minus 8. Okay, so let's talk about the different parts again. I'm going to get a different color. This is my base. This is my exponent. And then this is the part that goes on the right of the equals when I get there. Okay, so I'm not going to write log on the next line. This is at the point where I get this part isolated is where I rewrite it as an exponential. Okay, so I'm going to write 5. 5 is my base. 5 to the x minus 8, that's my exponent, equals 6y minus 7. Okay, so I want you to remember we are solving for y here. So now we need to undo what's been done to the y. So it's been multiplied times 6 and then subtracted 7. So the first thing I need to do is add 7 to both sides. Now what you need to understand is this part right here, is kind of like all one, it's like one term. So I can't add like the 7 to the 8 or anything like that because this x minus 8 is in the exponent. So that won't work. So all I can do is just rewrite 5 to the x minus 8. And if you want, you can put that in parentheses and then put that plus 7 right there. Okay, so then I've got 6y on the right side. So I'm still trying to solve for x, for y, I'm sorry, still trying to get the y by itself. So now I need to divide by 6 on both sides. And this right here is actually the answer. We're just going to rewrite it. We'll write, oh, it was a p. Let me get rid of that. Right, p negative 1 x equals, these canceled. So this y right here is the same thing as this. You can write y, I don't care. 5 to the x minus 8 plus 7. If you want to put that in parentheses, you can. You don't have to. Over 6. So this is the answer right here. So I think the most frustrating thing about these problems for me is that they don't turn out to be this nice number. It's like this big long thing, and I don't know if I've done it right or not. But remember, you can go over to Desmos and type it in, and then type in x equals f of y and all that, like we talked about during the lesson today, and you can check and see if it's correct. But okay, so this is number 16, and this is a log equation, and we're going to find the inverse by changing it to an exponential. So let's talk about what needs to be isolated again. Actually, I'm going to change this to y and then switch them first. X equals log, and then there's no base down here, so it's base 10. Let's write a base. Let's write a 10 there. 2x squared minus 7 plus 11. I'm sorry, I always forget to do that. That should be a y right there. 2y squared. Okay, so the part that I want to isolate, log and the base and the part in parentheses, that needs to be isolated. So I need to get it by itself by subtracting 11. Okay, so it's isolated. So now I can rewrite it as an exponent or as an exponential statement. So let's talk about what everything is again. This is my exponent. This is my base. Whoops, let me do a different color. This is my base. And then this is the part that's going to go to the right of the equals. Okay, so I'm going to rewrite this. And if you want to, you can switch it around. I'm not going to switch it around this time. 10 to the x minus 11 equals 2y squared minus 7. Okay, so 10 was the base, and you can make a little note if you want to. And then this is the exponent. Okay, all right, so now I need to get the y by itself. I'm going to add 7 on both sides. 10 to the x minus 11 plus 7. It just goes over here. You can't add it to the 11 or add it to the 10 or anything. You just rewrite it like that. Equals 2y squared. The next thing I need to do is divide both sides by 2. So 10x minus 11 and then plus 7 out here divided by 2 equals y squared. Not quite finished yet. If I have a squared, I need to square root it to get rid of the squared. Square root this side, square root this entire thing. Okay, so this is actually the answer right here. We're going to rewrite it. Y equals 10 to the x minus 11 plus 7 over 2, and then the square root of that. And that's all you need to do. I mean, you don't have to rewrite this in any way. That's actually the answer. And if you wanted to, you could write r, -1, x, whatever. But I would accept this right here too. I know these are really hard, and I probably won't give you one like this. I probably won't give you one this hard on a test or a quiz. But it's good practice for understanding what you need to do at what point. So down at the bottom, I don't think I did any of these. So let's look at, I think I did one of them for you on your actual PDF. Let's look at number 20. So number 20, the only thing I need to look at is domain and range. I don't even need to look at the other stuff up there. It tells me the domain of the original was 0 to positive infinity. And then the range of the original was negative infinity to positive infinity. The only thing I need to do is look at that and then come over to the inverse and switch them. I don't need to really look at the inverse or think about it or anything like that. I just switch it. This becomes the domain. So this right here is a domain, negative infinity to positive infinity. And then this becomes the range. So that was 0 to positive infinity. And I know there were some things up here, but it doesn't even matter what they are. I mean, I know you had like a log here, and then you had the inverse here or whatever, but it really doesn't matter because all you need to do is just switch the domain and range. So put this down here and put this up here. So hopefully that helps some, and it only leaves you with a couple of the inverses to find, and like 2 of the ones at the bottom, I think. So email me or text me if you have any questions about those. If you want to check to see if your answers are right or whatever, you can do that. And so yeah, hopefully this helped, and I'll see you tomorrow.